So I wanted to start off by setting the scene and give some context as to why we should talk about precision teaching in the classroom. And I'm doing that by sharing some quotes from reports of results of the Programme for International Student Assessment. And this is conducted by the OECD, and it's an international assessment of proficiency in academic subjects like maths, reading, science, and other subjects. And 15-year-olds from lots of countries like the US, Ireland, UK, China, and lots of different countries all take part in this assessment, I think, annually. And one of the quotes from this report in 2018 tells us that over 10 million students represented by this report and assessment in 2018 were not able to complete even the most basic reading tasks. Another report found that 1 in 4 15-year-olds didn't attain a minimum level of proficiency or mastery in reading or mathematics. So what this tells us is that all of the countries, the OECD countries included in this assessment, have some way to go towards reaching proficiency levels which were outlined by the UN Sustainable Development Goal for Education. Another quote from this report was that 10% of most socioeconomically advantaged students outperformed their 10% most disadvantaged counterparts in reading by around 140 score points. And that adds up to the equivalent of about 3 years of schooling in those countries. And those findings across the past decade that they have been doing this assessment have really remained unchanged. And this tells us that equity in education is a huge concern, and we still struggle to accelerate learning for students in areas of disadvantage in general. And finally, excuse me, probably the most concerning is that there has been no real overall improvement in the learning outcomes of students in OECD countries, even though expenditure on schooling rose by more than 15% over the past decade alone. And that tells us that focusing time and effort on effective evidence-based interventions and instructional approaches is of the utmost importance. So, you know, what we're funding and what we're putting our weight behind should be the effective interventions and the ones that are evidence-based. Okay, so let's look at some of the difficulties associated with learning in the classroom for a moment. When we have, or when we attempt to have students engage with academic tasks in the classroom, we can experience 2 different types of problems. So can't do or won't do problems. On the left, you have can't do problems. And they're experienced really when learners are missing materials. If they don't understand how to do a task, they can't do it. If they don't have sufficient time to complete a task, they can't do it. But the most serious can't do problems are related to difficulties or lack of prerequisite skills to complete the tasks and activities that are assigned during the class. And then on the right, we have won't do problems. And they're problems that are associated with students who can do the assigned academic work. They have the prerequisites, they have the time, the materials, etc. But academic engagement is then a matter of choice. And if we want to resolve issues around won't do problems, we need to ensure that our schedules and magnitude of reinforcement are managed, and that the response effort associated with target behaviours is managed too in relation to the contingent reinforcement. I have the reference for the paper that outlines these difficulties at the bottom of the slide. And throughout the slides, I have lots of references for you to take note of, but I can also send references after the workshop. So with can't do problems, we must identify those prerequisite skill deficits and implement effective strategies to facilitate mastery of skills for that learner. So if they have can't do problems with engaging in tasks like reading or maths, and they're missing some of those important prerequisite tool skills, then we need to find effective strategies to help them to master those skills so that they can engage with the reading curriculum and the maths curriculum, for example. And precision teaching is one of those effective strategies for teaching prerequisite skills to a high level of proficiency. So then what is the evidence base for precision teaching? So I was emphasizing that we need to look at effective evidence-based interventions. So actually recently a systematic review of frequency building and precision teaching was published in 2020. And it looked at studies in the literature that investigated precision teaching with frequency building. And they were evaluated in accordance with the What Works Clearinghouse standards. So study designs that didn't meet those standards were not included in this systematic review. So you can be assured that they're of high quality, those that are included. So they included a total of 11 studies and 170 participants. And they found that the overall results indicated that this is an effective method for increasing a variety of academic skills with school-aged children. So the review was only looking at PT and frequency building with school-aged children. And they found strong effect sizes for PT with reading, math, writing, fine motor skills, among others. So what is precision teaching? Precision teaching is a system for precisely defining, so selecting and defining the target skills and behaviours that we want to improve, for then measuring those skills and monitoring how the learner is doing with those skills, and then using that data and that measurement to facilitate how we behave, facilitate our decisions, and let the learner influence whether or not we change what we are doing in instruction. And this is an approach that can be used alongside any curriculum to ensure fluency and to monitor a learner's progress. And precision teaching, when we're implementing it, has a specific process. And the process is that we first pinpoint the target skill or the behaviour that we're trying to improve. So that's where we select and define that behaviour. The second stage is that we record, and that's where we measure that target skill and behaviour, and we chart our data on a standard Celeration chart. And then the final part of that process is to make instructional decisions based on learning pictures on our standard Celeration charts. So we're making decisions based on that data about the effectiveness of our instructional approaches. So I'm going to basically take you through the steps of precision teaching today as much as possible. So kind of take you through the process, what the process involves, but also why we do some things like measure frequency of behaviour and use a standard Celeration chart. So the first step in the process is pinpointing. This is defining and selecting the skill or behavior that we're targeting for improvement. So a pinpoint should be an observable movement that you can count. It's a precise description of behavior that directly identifies observable actions or movements. So one of the guiding principles of precision teaching is that we focus on observable behaviors. So we need to ask ourselves, when we're pinpointing a behavior, does the behavior involve an observable movement? So does it pass the dead man's test? And the dead man's test is, if a dead man can do it, it's a behavior. We need to ask ourselves, does the movement have a complete cycle? So does it have a clear beginning and end that we can identify? And can the learner repeat the movement? So the answer should be yes to all of these questions when you're defining your pinpoint. So at this point, what I wanted to do was get you to engage a little bit and to help us to understand those observable movements. Those observable movements that we can count. I want to give you some examples of good and bad pinpoints. And for each one, can you tell me whether you think it's a good example of a pinpoint or a bad example of a pinpoint? I'm going to turn my camera on here. Michelle, this is where we were, Michelle has the poll for you here. So the first one is, on task, do you think that that's a good pinpoint? So yes, it's a good example, no, it's a bad example, or you're not sure. So most of you went with no, that's a bad example, and that would be correct because it's not really repeatable and there's no clear beginning or end. So yes, that's excellent. So the next one was state the correct answer. Is that a good pinpoint? So if I were to ask you a question about maths and you state the correct answer, is that a good pinpoint? Yes, it's a good example. No, it's a bad example. Or C, you're not sure. It's just fine. So I think we got the results of that very quickly. But it's looking like most people were going with yes. We can move on to the next one. So yes, that's a good pinpoint. Refrained from swearing. Oh, sorry, Michelle, I don't know. Yeah, we're here now. We have refrained from swearing. Yes, that's a good example of a pinpoint. No, that's a bad example, or you're not sure. Oh, Michelle, somebody has said that they can't see the poll. Okay, well, we have, I see your comment there. Sorry that you can't see the poll. Michelle will try and let that hopefully. Okay, so the results are back for that pinpoint, and most people have said no, which is great. So you're refraining from something, you're not doing it. It's not really, it doesn't pass a dead man's test really if it's something you're not doing. High five. Is it something that is,
yeah, sorry if I opened the wrong one.
We'll do a different one. So, understands a math problem. Yes, that's a good example. No, it's a bad example, or we're not sure. Great. So, yeah, most people are saying no, and that is a good answer. Some people have said yes. So the reason that this is probably not a good example of a pinpoint is that there's no clear beginning or end. It's not really something that's repeatable, and not necessarily, it's not a very objective, observable behavior to observe, because my observing somebody that understands a math problem might look different to how somebody else observes it. Will we just do one more, Michelle?
I was just going to suggest, Aoife, if you don't mind, because there's a couple of people having some trouble, so maybe you can ask the question and people can respond in the chat instead. Okay?
Yeah, no problem. I'm just going to move to the chat. So you have to make sure that you reply to all panelists so that I can see it too. So let's look at the, how about read words? Is that a good example? And you can put yes, Y for yes, and N for no. Okay, answers are all coming in, and everybody is saying yes. Most people. Yes, it passes all of those tests. Brilliant. Yeah, exactly. Read words, that's very good. What about one more? Remain attentive. Is this a good example or a bad example? Okay, all the answers are coming in there again. And yeah, the majority of people are saying no, and that's very good. That's not a good example. It's a bad example. The clear beginning and end is just not there for that. So we wouldn't use that as a pinpoint either. Okay. There are some other examples there that you can have a look at in your own time, but I think everybody kind of has a really good understanding of this, so I'm going to move on. So I'm just going to disappear here again and draw your attention back to the slide. So other things that we need to consider when we're pinpointing behaviours are, first of all, is the behaviour a high priority? Does it relate to the overall curriculum goals? It's good to select prerequisites that will help learners learn other skills. So, for example, letter sounds and blending, those kind of skills are important because they can be applied to reading lots of different words. We also want to ask ourselves, is the behaviour within the learner's current repertoire? If it's currently within their ability to perform the movement, then that is a good pinpoint. If pinpoints are beyond the ability of the learner, it's going to result in frustration and a learner that won't experience much success. We also need to provide the learner with opportunities to learn, so we're not going to pick a pinpoint that's already performed at a proficient level. We always pinpoint a correct and an incorrect movement. So for reads words correctly, we're also going to measure incorrect words read. So we always have that pair, an accuracy pair. We also, if we're trying to decrease the behavior or a deceleration target, we're also going to teach and measure an acceleration target. So we're going to choose a fair pair. So maybe a communication skill. And the last one is the behavior easily measured by teachers or learners? So is it clearly enough defined so that anybody can easily measure it? And does the pinpoint that you've chosen occur at times when it's easy to observe? And I'd recommend that you, if you're interested in reading more about this process, that you get the Precision Teaching book by Kubina and Urich in 2012. And there's a lot more information on the different things that you should consider for pinpointing behaviours. And the second thing we need to take into account for pinpointing is our learning channel. So a learning channel directly describes how the learner comes in contact with the environmental stimulus and how the learner responds. So it's a description of the environmental stimulus and the response. An example is if we're reading words out loud, we would describe that as see, say words. So we're seeing the word and we're saying it. That's how we're inputting the information and our output. If you were reading to yourself, it would be see free. So we're seeing the words, but we're reading to ourselves, and that's called free or think in the learning channels. If you were answering a question here in the chat, that would be hear, write, or type. So you're hearing the question from me and you're typing the answer. So in order to aid us in choosing learning channels, we use this learning channel matrix. I'm sorry, it is a little bit fuzzy. And this describes the ins and outs of learning channels. So you can see the ins or the inputs on the left. So think, touch, taste, sniff, see, hear, feel. And then you've got your outputs at the bottom. And you can decide, looking at that channel, what input and output are the most appropriate for your pinpoint. So I'm going to go back to you again for a moment, and I think we'll use the chat again. So could you use the chat to identify the learning channel for each of these examples that I've given you on the right, and think of what the linked unit of sensory in and behavioural out might be. So for example, the first one is matching objects without a vocal verbal prompt. So just seeing objects and matching them. See do, someone said. See match, see select, see match. Okay, see do. Yeah, so most people are saying see match or see do, which is great. What about saying math facts from memory? Okay, so answers are coming in now. Yeah, so most people are saying think, say, or free, say, which is brilliant, excellent. What about writing answers to a written multiple choice question? Or to written multiple choice questions? Yeah, so most people have said see write or see select, which is very, very good. Either is fine. See select. You see the question on the paper in front of you, and you select the answer. What about reading a passage to yourself? Yeah, answers are coming in. So you're reading it. Somebody has asked me, is it aloud to yourself? No, it's to yourself in silence. Yeah, okay, answers are coming in. Yeah, so C, think, or C, free is what most people have said, which is great. Brilliant. C, say would be if you were reading the passage out loud. This is brilliant. Thank you so much. As Michelle said, thank you for participating. And then what about if you were answering a question in class? So you were in a classroom and the person asks you a question and you tell them the answer out loud. Right, all the answers are coming in. And most people have said hear, say. So you hear the question, you say the answer. Excellent. What if you were telling a story? This is brilliant participation. Thank you so much. Okay, answers are coming in for that now. So telling a story. Yep, brilliant. Most people are saying free, say, or think, say, which is brilliant. So it's from memory, and your output is saying. What about if you were following a recipe to cook a meal? Okay, great. Answers are coming in. Okay, brilliant. Yeah, most people have said see-do, which is brilliant. Thank you so much for your participation. I think everybody pretty much has the hang of that, so that's great. We have two more examples, but I don't think that we need to do them. They'll be on the slides for you. Yeah, so you see the recipe and you cook the meal. So that's your output. Great, okay. Thank you so much, everybody. And we'll move back to the slides. Okay. So then when you're choosing your learning channel, you just want to ask yourself, what learning channel will the learner use after instruction? Because when the learning channel that you teach differs from the learning channel that a person is evaluated through, that can make a huge difference. So if you're doing an exam and your output is writing, then maybe you need to increase your fluency with writing as opposed to saying the answers. And just, take into account that the learning channel really does have an impact if you're teaching through one and assessing through another. And then you need to ask yourself if you need to teach through more than one learning channel, because we don't really know if it generalizes, and quite often it doesn't, and we need to, teach somebody to write and say skills. So maybe say math facts out loud, but also write the answers to math facts. Okay. Great, so we've covered pinpointing. And we're going to move on to step 2, which is record. So this is step 2 of precision teaching. And recording involves two different things. It involves counting the behaviour or skill and then charting that skill on the standard Celeration chart. So once we have our pinpoints, we count. And in precision teaching, what we count is rate of behaviour or rate of skill performance. And we refer to that as frequency in precision teaching. Frequency is the number of occurrences of the skill or behaviour over time, so within a specified amount of time. For example, number per minute, and that might be that somebody reads 80 words in a minute. They might write 60 letters in 30 seconds. They might write answers to 120 math facts in 2 minutes. So the time involved is very important. We're counting rate. So we need to know how many behaviours occurred, and within what time frame. And when learners achieve a certain frequency of performance with their pinpoint, we say that that skill is fluent. Okay, so back to you in the chat. I'm going to talk about why we target frequency and fluency as opposed to count without taking any account of the time involved in doing the skill. So if you think back to school, any of your schooling, how is mastery conventionally defined or measured? So when you learned a skill and you were assessed on that skill, what was the how was it measured? How was your mastery measured? Do you remember? Okay, so answers are coming in here. We've got percentage correct. Somebody said speed and accuracy. We've got exams, accuracy correct, and fast, percentage correct, percentage. Oh, it's too fast for me to read all of them. But exam score, exam percentage, standardized testing, percentage, grades. Percentage. Okay, excellent. Thank you so much. It's really helpful to get all of those answers. Percentage. So the majority of people are saying that percentage is how mastery is usually or conventionally measured in schooling. So that is usually the answer that I get to that question. Usually there's an exam score and a mark or a percentage correct. And if you get 100% in your test or your assessment, it's, I suppose, generally accepted that you've mastered that content. But we're probably missing something in terms of just looking at percentage correct as a measure of mastery or proficiency. So if we take the example of 2 university students that are learning a second language, so let's just say they're learning French for the example, and we say that one of those learners or students goes to France for a year, one does not. So one is practicing their skills beyond accuracy at a high rate and at a fast pace, and they're applying those skills, and the other is not. But both take the test, and they take the same test to test proficiency with that language, and they both get 100%. We know that one is more likely to be more proficient than the other. We know that the person who's been to France and has spoken with the natives at a high rate is actually going to be more proficient or have mastered French or that language a lot better. However, when we measure percentage correct, we kind of miss that level of proficiency and that level of mastery. So that kind of suggests that we're missing an important step in achieving mastery of skills and achieving proficiency. So that level that we're kind of missing is behavioural fluency. And behavioural fluency is defined as accuracy plus speed of responding, and it enables competent individuals to function efficiently and effectively in their natural environment. So, you know, if we build a skill to fluency and practice it further, it results in more useful skills that can be applied, you know, in the areas and in the places where we want that skill to be applied. So, for example, that student who's learning a language is able to use that skill proficiently when they go to France or when they're speaking with French speakers. So, getting that level of mastery allows individuals to function efficiently with the skills that they have been taught. And actually, that level of proficiency or fluency is recognized as key when learning languages or playing sport or playing a musical instrument. But maybe not so much in other areas. So in the chat, can you tell me if you can think of a skill that you're teaching at the moment that might benefit from practicing to fluency? Addition. Okay, we've got maths, very quick responses, PECs, sight words, casting common items, reading. Okay, EdMark reading, sight words, conversations is a really good one. Sorry if I don't read out your comment, they're coming up very quickly. So solving math problems, reading letter sounds, emotional regulation skills, multiplication, timetables, typing on the keyboard, excellent. Yeah, solving math problems, a new language, absolutely. Yeah, okay, brilliant. Washing hands, yeah. Right, yeah. So, yeah, there are a lot of skills where maybe fluency, responding to or initiating greetings, that's a really good example. You know, when it's an example I was going to nearly give to you is that these social skills and conversational skills, when we're teaching language, it's so important that they're fluent so that we can apply those language skills in conversation fluently, because it's kind of what's expected from the other person when you're engaging in a conversation. So social skills, really, really important. And then, of course, everybody has talked about the math skills and reading skills. So, you know, reading skills, knowing or having a high level of proficiency or fluency with reading allows you to apply those reading skills to learning and reading about other subjects and topics. When we talk about math skills, we want to get fluency with your math facts and your math timetables, so that you can apply that to learning about long division, and then you can apply them to more complex mathematics tasks, and then on to engineering and science, etc. So even though it's not really across the board accepted that this level of proficiency or fluency is key in learning academic skills or language skills, and any of the other kind of examples that you gave, they probably should be taken into account. Okay. Thank you again so much for your participation. Brilliant. So this idea or notion, I suppose, that high frequency criterion for mastery in precision teaching, and it didn't just come from nowhere. Ogden Lindsley developed precision teaching with colleagues and students in the 1960s, and when he was working as a professor in education. Before this, he was a student of B.F. Skinner, and Skinner used rate of response as his primary measure of behaviours in his experimental analysis of behaviour. And Ogden Lindsley believes that it was important to retain this measure of behaviour in practice. So he believes that you have not accurately described behaviour until you have stated its frequency. And much research has shown that our best measure of an operant strength is its frequency. So an operant is very strong when it can be emitted often within a given period of time, and it's weak when it's emitted rarely. So these frequency measures supposedly had the ability to accurately represent the probability of future occurrences. And they had also found that in the laboratory research that frequency was 10 to 100 times more sensitive to changes in procedures than that percent correct. So he, believed that this was the superior measure and the only measure really that you should use when measuring behaviour and skills. Okay. And then there were lots of applications of precision teaching in education, using this rate of response as the measure of a proficient skill. And that led to discoveries in terms of higher performance frequencies or fluent performances. And those discoveries were made from thousands of standard Celeration charts and PT interventions that were put into practice. So precision teachers early on found that achieving fluency resulted in more useful skills, like we talked about. And they resulted in behaviours and skills that were retained long after they were learned, that individuals could remain on task or endure for sufficient periods of time to meet real-world requirements, even in the face of distraction. So the plain English word for that would be students are able to sustain attention to that task or skill for longer periods of time, and also able to apply those skills in new situations. So if we take the example of our individual learning a second language, we would be saying that the person who went to France and practiced French will probably be able to speak that language and be fluent in that language long after they've learned it. They'll be able to continue with conversations for longer periods of time and sustain the same level of proficiency and attention in that conversation. So you can imagine yourself in that situation trying to talk to somebody in a different language and how difficult it would be to sustain attention. But if you're fluent with those skills and it's not very effortful to think of the grammar and the vocabulary, you're going to be able to sustain a lot more attention to the actual conversation that you're having. And you can have those conversations, in noisy environments, distracting environments. So if you're in a restaurant or a pub, you'll be able to continue with that conversation in a different language. And also that, you can conduct conversations with different native speakers. So it's not just one person. You're going to apply that across lots of different situations and scenarios. And these critical learning outcomes that were discovered associated with fluent performance started out as REAPS, which was Retention, Endurance, Application, Performance Standards. And that was, I suppose, developed by Houghton in the 1980s. And more recently, it has become MESAG, which stands for Maintaining That Behaviour, Enduring on the task or the skill, Stability in the face of distraction, and being able to apply those skills in different situations. And generativity involves the emergence of novel behavioural repertoires without actually explicitly instructing on those skills. So it's combining fluent prerequisite skills to form new repertoires that aren't explicitly taught. And then just in terms of, have these outcomes been evaluated in control studies? And this is just an example of it's a snippet from a systematic review of behavioural fluency and maths interventions over the last 20 years. You can see the reference on the left, and then REANS, which stands for Retention, Endurance, Application, Maintenance, Stability, and just gives you an idea of the number of studies that are actually evaluating those outcomes and whether or not they occur as a result of achieving fluency with those skills. And I did my own kind of literature review on not just maths, but academic skills in school-age children. You can see the studies on the left here who looked at precision teaching and fluency building or frequency building with different academic skills and whether or not they measured retention and maintenance, endurance, application, generativity, or stability. And I think what we can see is, empirical investigations of these critical outcomes are emerging. But if it was anybody's desire to conduct research in this area, I think that it would be a good area to focus on, to conduct a little bit more research, because you can see that stability on this slide isn't one that's included that often or investigated. Yeah. Okay. So then that's why we look at frequency and fluency. And now we need to talk about how. So again, this is one of the elements of the workshop that had to be cut down quite a bit because of time constraints. So we'll just do kind of a brief overview of how we count. So the first thing we need to do is decide on the counting period. How long are we going to count for? So the general and most common counting time is 1 minute, but sometimes we might count for 30 seconds if it's more appropriate for the skill that we're counting, or if we need to build a learner's endurance. So at the beginning, a learner may not be able to maintain that high rate of responding for 1 minute. So we can cut down that timing to 30 seconds or even lower and build up their endurance so that they can sustain that rate of behaviour or skill over a minute. And then some skills just take a little bit longer, and in order to provide more practice opportunities, we might conduct longer timing. So for example, the whole number of computation problems or writing answers to word problems. So we've decided how long we're going to count for, and then we need to decide what's the frequency aim range. So how high a rate of behavior do we need to achieve before something is fluent? And so we might say something like, I'm building fluency with math facts, and that person should be fluent once they can do 60 to 70 within a minute. So we set that frequency aim range of 60 to 70 per minute. And we say that once that person has achieved 60 to 70 per minute, they've achieved the aim or the goal. So the way we choose our frequency aim is we sample behaviour or skills with fluent learners. So if you have learners who are already fluent in a particular skill, we'll do 1 minute timings with them and see what their rate of behaviour is and set that as our goal. A lot of the time we can look to the research on performance standards, which is the same thing as the frequency aim range, So there's lots of papers and research out there that tell you or designate a frequency aim range for a specific skill. And again, if you look at the precision teaching book, it actually has quite a few frequency aims designated and outlined. And then, of course, the other way of knowing if something is fluent or has reached a high enough rate is that we can check whether it's been retained, whether the individual can endure or stay on task for longer. So if we were doing a 1 minute timing, we could test the rate of behaviour during a 5 minute timing and see if that rate of behaviour is maintained. And then application can be tested by seeing if somebody can actually apply that skill to different materials and situations. So basically I've just given you, I'm not going to dwell on this because obviously I'm aware of the time counting down and how much I have to cover, so we won't go through these, but you'll have the slides afterwards and they're just examples of some pinpoints with their recommended frequency aim ranges. Okay. And then very often what we will do in conjunction with precision teaching is, build that rate of behaviour using frequency building. And frequency building is the timed repetition of a selected behaviour for your pinpoint, followed by performance feedback. So we do, say, a minute timing, and then we'll look at the correct responses, and we also look at what we call the learning opportunities, which are the ones that the individual have gotten incorrect. And we might do a little bit of practice on the learning opportunities or the incorrect responses, and give reinforcement and positive feedback for the correct responses. So we want to give positive reinforcement for correct responses, but also for kind of increasing that rate as well, depending on the learner and the stage that they're at. So these frequency building timings and feedback can be incorporated into any instruction. And we can keep implementing frequency building until we've built fluency to that criterion, so that fluency aim range. And most of you have probably already heard of FastMouth before, which are also a really good approach to learning different basic concepts, definitions and terms, where we, have a definition and its meaning on the back, and you can engage in explicit fluency timings yourself and build fluency with those kind of core concepts. Okay, so that was counting. And we're still on step 2, which is recording the behaviour. But now we're going to talk about the standard celeration chart and recording data on the chart. Oh yes, and Michelle has sent you a link there in the chat with a little YouTube video that's freely available so that you can have a look at what frequency building looks like with phonic skills. Okay, so the standard celeration chart. Once we have counted our behaviour, we chart our frequency measures of our skill on the standard celeration chart, and we do that on a daily basis. And in doing so, we develop a learning picture to monitor performance. And then when we have this learning picture, we can make decisions about what we're doing, our instructional approaches, and our goals. And ideally, you want to see a learning picture a little bit like the one on the left, where we see correct responses accelerating and we see our incorrect or learning opportunities decreasing. Can everybody see that chart okay? You're all still with me? Excellent. Thank you so much for letting me know. Okay. So again, like I explained the frequency and fluency and why we do it, I'm going to try and explain to you why we would use a standard celeration chart as well. So most people, if you are, I suppose if you're a behaviour analyst or trainee behaviour analyst, then you'll have come across an arithmetically scaled line chart before. So you might call it a linear graph or equal interval graph, etc., or an add-subtract graph. And we use these quite a lot in practice. And on this graph, the horizontal axis shows the passage of time along the bottom, and on the vertical axis, each interval of space, so between 10 and 11, 11 and 12, changes by addition and subtraction. So equal distances represent equal additions or subtractions on the scale. So I'm going to use an example from the Precision Teaching book, actually. We're going to look at this example to differentiate between equal interval and standard celeration charts. So if a student or a learner learns to read 6 more words this week, then basically we would chart plus 6 words on the graph. So you can see the little blue lines, hopefully, that I have beside the equal interval graph there, and you can see that that's what it would look like. That's what the increase would look like if we were charting on the equal interval graph. So whether or not the learner goes from 0 to 6 words in the week, or they go from 70 to 76 words in the week, that change in behaviour, the change in the skill, will look the same on the equal interval graph. And that's a good graph then for graphing absolute change in behaviour or skills. And then we have the standard celeration chart. So it's a semi-logarithmic chart, and it's another option for conveying information on a learner's performance. And if you look to the bottom axis of that chart, the horizontal axis is also an add scale and shows equal intervals of time. So basically it's consecutive days. You can see 0 to 14, that represents each vertical line there represents a different day. So moving from left to right, time appears in equal intervals, and every standard celeration chart represents, or each of these daily charts represent 140 days, and that was to kind of mimic a school semester. So that's the horizontal axis. However, the vertical axis is a multiply scale or a logarithmic scale. And on these logarithmic scales, equal intervals of space on the left show equal multiplications and divisions. So we're not adding and subtracting up and down this scale, we're multiplying and dividing. So you can see that the space between, hopefully you can see, the space between 1 and 10 looks the same as the space between 10 and 100, and that looks the same as the space between 10 and 1,000. Or sorry, 100 and 1,000. So equal intervals on this chart show equal ratios or proportions of change. And this is aligned with counting logarithmically. So instead of adding on by 1 in each count, we multiply by a number each time. Let's just take a closer look at the scales side by side. On the left here, on the add subtract scale, you can see that we add 1 as we move up the vertical axis. So you see 17 to 18 is plus 1, 18 to 19 is plus 1. It's the same as 1 to 2 and 2 to 3, etc. It's adding 1 all the time. But if we look to the right at our standard celeration scale, we are multiplying as we move up that axis. So you can see that it's 1 times 10 is 10. Then we've got 10 times 10 is 100, and 10 times 100 is 1,000. So we're multiplying up the scale. So each times 10 is the same distance, and similar distances on this scale are similar proportions. 1 is a tenth 10, 10 is a tenth of 100, and 100 is a tenth of 1,000. So basically, using this scale, we can represent proportionate or relative change. So if we go back to the example of a student learning to read 6 more words, their absolute change in the behaviour is still 6. But if they learned 3 words last week, and then that went to 9 words this week, 6 more words, then the proportionate change from 3 to 9 is a 200% increase, or a times 3 growth in that skill or behaviour. And that's represented on the chart to the right, where you can see the little red mark. So that's a big change, and it's substantial and significant. And we're kind of seeing with that how fast learning is changing over time, and representing that on the chart. But if we take the same example and change it around a little bit, so that the learner has still learned 6 words this week, but last week they actually knew 250 words, and this week they know 256. That's actually a proportionate change of 2.4%, or times 1.024. So, you know, in comparison to what they had last week in reading skills, 6 more words isn't a huge amount more. It may not be as significant as learning 6 words when you only knew 3 before that. So it kind of puts the significance of the change or the increase in a skill into perspective. And the standard Celeration chart can represent that proportionate or relevant change. So hopefully, again, you can see the red marks that I have. It's a little bit blurry, actually, on the left-hand side here. And the lower one is the change from 3 to 9, and the higher one is the change from 250 to 256. So you can see that the proportionate change is represented as kind of smaller or less significant on the chart. Okay, hopefully you're all still here with me. So just in the chat, can you think of any skills or behaviour that you are currently teaching that would benefit from understanding this relative change in the behaviour as opposed to the absolute change? So a behaviour that you're teaching where you want to know how fast those frequencies are multiplying or dividing across time. So if you're teaching a behaviour or a skill and you want it to continue increasing at a fast rate, oh great, okay, vocal imitation, excellent, reading, discrimination of pictures, community science, acquiring new vocabulary, big time, tasking, manding, yes, excellent. So requesting skills and being able to label things in the environment, math skills, vocabulary, somebody else has said, and that's really important. Requesting, excellent, yeah. Very good. So, you know, when you think about manding or requesting and teaching an individual or a learner to request different things, and maybe you're working with an individual with autism or an individual with a language delay, and you're teaching them these new language skills and new requesting skills, we probably need to take into account the exponential increase and growth in requesting and language skills that we see in typically developing children, and understand that kind of exponential growth and try to monitor our behaviour and our manding and requesting skills that we're teaching in the same manner so that we can compare and understand whether or not the growth in those language skills is akin to, I suppose, that of a typically developing speaker. Right. So a lot of people have said requesting and interverbals and learning new vocabulary, and somebody has said math skills as well, so absolutely. And then when we think about maybe decreasing behaviours as well, you know, we can target behaviours or skills for deceleration as well. So, you know, if you think about a severe challenging behaviour that's occurring at 200 times per day, and we implement an intervention and it decreases by one behaviour per day, is that fast enough? You know, do we need that to be decreasing faster? We might change that intervention if it's only coming down once per day, like, you know, one behaviour a day. But if we had 10 behaviours per day to begin with, and our intervention reduced that by 1 per day, we might make a different decision about our intervention. And we might say, yeah, let's keep that intervention in place because it's decreasing. And, you know, for us, it's decreasing a fraction of the rate. Thank you so much again for all your responses. That's brilliant. So this is a little bit of a nerdy slide for you, but if you want further clarification around thinking on a logarithmic scale, I recommend this video, which is on this something called Vsauce YouTube channel, and he chats about how we all think in this way and how our brains perceive the world around us on a logarithmic scale, and it's believed that almost all of our senses are multiplicative, not additive. And then having that intuitive sense of logarithmic scale built into your brain is probably an advantage when it comes to natural selection and survival because of proportion because often proportion actually matters more than absolute values. So he gives the example, these are not just random pictures of lions on my slide. He gives the example of surviving in the wild, and if you find yourself in the company of one lion, and then one lion becomes two lions, then you've doubled the trouble that you're in and the danger that you're in. But if you found yourself in the company of 70 lions and one more lion was added to that situation, you've not really changed your chances of survival substantially. And so proportionate change is really, really important in that regard, and that's how we would think naturally. He also talks about how that works to our disadvantage. So if we're making savings or trying to make a saving on purchases that we are making, we might make a huge effort to save 5 pence or €5 or 5 cents even of a 10 pence purchase, because that would be half the value. But if we were buying something for £100 or €100, we probably wouldn't make that much of an effort to save that 5p, even though it's, in absolute terms, it's the same amount of money. But that way that we think on a logarithmic scale, we think proportionately kind of impacts our decisions. And Lindley, who developed decision teaching, would have said that performance lives in a multiply world, not an add. Okay. So that was one reason for using the standard celeration chart, and the other reason is standardization and consistency. So this is data taken from the chart book, which is freely available, and I would highly recommend people to look into and use as a tool for charting, because we're not going to get to that very much today. It shows that when we chart or graph data, the same data on differing scales, so you can see one scale is 0 to 50, one is 0 to 150, and on different kind of size graphs and charts, we end up getting very different learning pictures. And that makes it very difficult for us to compare data when we're teaching similar skills, or to identify any kind of trends in the data that help us to make instructional decisions. So we need to be very wary of the scales that we are using to make decisions on behaviours and skills and instruction. So the standard Celeration chart is standardised. Its units of measurement are, first of all, our frequency that we've talked about, which is the count of behaviour over time. And you can see the little red around kind of one frequency that's been charted there, and for correct and incorrect responding. And the other unit of measurement that we have is Celeration. And Celeration is count of behaviour over time, which is frequency over time. So we want to see basically how fast our frequencies are multiplying over time. That's how we'll get to see that proportionate change in behaviour. So Celeration, or that learning over time, is evaluated using the slope of the line that you've drawn through your data points. So hopefully you can see the little red line on the chart to the right, and that is your Celeration line. And you look to the slope of that line to decipher how fast learning is occurring over time. So take this example. The slope of this line shows us that there's been a 20% growth from the first data point to the last, and it times 1.2 Celeration. Okay? So we can tell that from the slope of that line on the chart. And this diagram is taken from a very good paper that I'd recommend to everybody with interest in this area. It's an example from Potts et al. And on this chart, you can see that a line drawn from the lower left corner of the standard Celeration chart represents, from the left corner on the bottom, to the top right corner where you can see the ×2 in the middle. So on every chart, it's standardized so that a line of that slope and at that angle represents a doubling of frequency. So a ×2 acceleration in that behavior. So these slopes are standardized, or they're standard accelerations, meaning that we can quickly identify learning rate over time for any skill or behavior that we're charting. And you can see, hopefully as well, to the left, the little blue picture that I've pasted in there is called a standard acceleration fan. And you can see that it shows you the slope of the lines. Now that's to the left of every standard acceleration chart, so that you can see the slopes of the lines and what acceleration that they represent. So you can see a ×2 acceleration, hopefully. You can see a much steeper angled line represents a ×4 acceleration, a quicker pace of learning. And then we can also do the same for our deceleration targets. So the slopes pointing downwards are divide by 2, divide by 4, etc. And we can tell based on that slope, the slope of that line, how quickly a behavior or skill is increasing or decreasing over time. So we can use that standard acceleration fan to estimate the slopes of those lines with our data, but we also have calculations and acceleration finders that we use with the chart that will calculate that for you very specifically. But obviously that's beyond the scope of an online shorter workshop. But just so you're aware, there are more precise ways of doing it. And of course, if you're using electronic charts, I'm sure it does it all automatically for you. Okay. So when we chart the frequency, and we've got 5 to 7 data points representing frequency, we can draw a line through those data points, a line of best fit, and then compare it with these standard accelerations to see how quickly our skills are increasing over time. Okay, so in summary, why do we use the standard acceleration chart? We use it to monitor learners' performance over time, make decisions about our teaching approaches. We know that we can use it if we want to look at proportional changes in behaviour, and we can determine the significance of changes in behaviour beyond the absolute change. And that might actually change how we behave ourselves when we're making decisions about instruction. And the last reason is our consistent sharing of information. So, you know, if we're all using those kind of same charts and we're collaborating and comparing data on the same skills, it's much more easy to do that on a standard chart. And when we're using this chart, there's, you know, it's much easier to identify meaningful learning trends from those charts. Okay. So this is a part of the workshop that would be much expanded if I had you in person, but we're just going to talk a little bit about not just why we chart, but how we chart. And I'm really just going to do 1 or 2 slides to show you the basics of the chart. So to begin with, we need to complete the bottom of the chart where we fill in, you know, who the supervisor is, what the organization is. On the left, we want to fill in who's counting the behavior, who the learner is, and what behavior that you're actually counting. And then we want to fill in the top of the chart. So if you look at the darker vertical lines, they're every 7th line, you can see that they are Sundays. So every darker vertical line is a Sunday. So when we fill the date in at the top there, we fill in the Sunday of the week where we're starting to count. And then we fill in across the chart all of those Sunday dates. And then we can find our day lines by counting along from those darker Sunday lines. And the next thing we can do is indicate the count time. So we've decided how long we're counting for, but we need to indicate this on the chart. Everything on the chart will be converted to minute or per minute data. So we need to indicate on the chart how long we were counting for. So you can see on the right-hand side of the chart that it's actually fairly clearly outlined where we indicate the count time. So you can see 1 minute, 2 minutes below that, 5 minutes, 10 minutes, 20 minutes, etc. I actually think it's a little bit clearer on the next slide. My apologies. I lost myself there for a second. So if we were counting for 1 minute, that would be indicated with a dash, which is called the record floor. So you can see that on the left-hand side. So I found 1 minute on the right-hand side of the chart, and I'm going to indicate that that's how long I'm counting for on that 1 minute line. But we also might count for 2 minutes, 5 minutes, etc. And if you're counting for 2 minutes, you move that dash down to that 0.5 line. Okay? And so the longer we're counting for, the more that line moves further down the chart. So if we're counting for shorter periods of time, 30 seconds, 20 seconds, you can also see those indicated on the chart on the right-hand side. Okay. And that's the most basic way of finding that counting time. But we can also calculate it. So by 1 over the number of minutes that you're timing for. So 1 over 2 is 0.5, and 0.5 on the left-hand side is where you would put your floor. But I don't want you to worry too much about that because it's very simple to find them on the chart, and we can also use our Celeration finders to find the counting period floors. Okay. And then we chart our accuracy pair, and they're indicated by a dot for an acceleration target and a little X for a deceleration target. So what's charted here is 10 correct and 5 incorrect or learning opportunities. So we have our minute floor, so we're counting for a minute, and that learner got 10 correct and 5 incorrect. And that's how we indicate it on the chart. And I've just pointed out there as well, the counting lines for 20, 50, 200 and 300. So we have to count up the chart to find those counting lines. And when we're counting between 1 and 10, we count in ones. When we're counting between 10 and 100, we count in tens. And above 100, we start counting in 100. To find our counting lines. So basically what you need to take from that is your charting conventions are to indicate the timing and how long you were counting for, that a dot represents your accurate responding and a little X represents your incorrect or learning opportunities. And then once we have 5 to 7 of these frequencies charted, we can draw that line of best fit, and we can investigate the slope of that line and look at how fast learning is happening over time. The other thing we indicate on the chart is our frequency aim range. So if we want to get 40 per minute correct, then that is where we would put our aim star, we call it. So our aim star is basically just like a capital A. And the aim is indicated on the chart by the crossbar of that A or that aim star. So you can see there that the crossbar in the A is on the 40 counting line, and that indicates that our aim for that learner for this skill is between 40 and 50, because the top point of the A is on the 15. We also want to put that aim star on the day that we hope that the individual will meet that aim, and we indicate the day by putting the point of that aim star on the day line. We expect the individual to meet their goal. And we can also have our deceleration targets, which is the same thing, but the aim star points down for deceleration targets. Okay. So I see there are some questions there that we might take at the end, if that's okay. Okay, and then using the chart, we can predict future learning by drawing a minimum acceleration line from our first data point. So we do our first timing. We're counting per minute. The individual has gotten 5 incorrect and 10 correct. And now we're going to draw a acceleration line, or minimum acceleration line, from that first data point. And again, we can use our little ruler acceleration finder to help with this. But what I've tried to draw there on PowerPoint slides is approximately a ×2 slope. And, you know, if the learner is doubling their learning per day, they should reach that goal in a couple of weeks, exactly where I have put the aim star, right? So we can estimate when a learner should achieve their aim if they're learning at the pace that we want them to learn at, so ×2 for whatever acceleration that we've decided for that skill. So we estimate when they'll achieve the aim, and then we can also monitor their acceleration and their learning across time. So if the data points are falling well below that minimum acceleration line, we might make a decision to change what we're doing and change instruction, because maybe we're saying that we need this skill to be learned at a faster rate, and it needs to be learned by a specific date maybe in the school term. So we need a faster rate of learning. And sometimes the data points might go above the acceleration line, and they may be too steep, and we might decide that the pinpoints that we've decided on are too easy for the learner, and we need to adjust those as well. So it's a really, really useful tool in monitoring learning. So apologies again for just a brief look at the standard conventions of the standard acceleration chart. There's obviously a lot more to it. And for that reason, I've just added a slide here for resources. So the Precision Teaching book is a very good resource for learning how to chart, and also that the chart book, which is available online freely, is a very good one as well to kind of show you how to chart and show you all the different conventions. So I'd recommend looking into that. And again, I think that Michelle will send an email out after, so we can I can send you those references in that email as well. Okay, finally, our last step of precision teaching is to make instructional decisions based on those learning pictures. So we can use the learning pictures to decide on how to proceed with our teaching. If somebody, for example, meets an aim, we will change because they've met their aim, so we'll target a new pinpoint. If the acceleration data is decelerating or just plateaued, we're going to change because we want to increase that rate of learning. Or if the deceleration data, or if you're teaching a skill, the incorrect responses are accelerating or plateauing, they're not decreasing like you want them, we're going to make a change to instruction. And I hope that you can see this, but if you can't, I recommend reading this article anyway, which is Precision Teaching, Discoveries and Effects from the Journal of Applied Behaviour Analysis, which was written by Lindsley. And it's just a nice example to refer to, his own example and description of Lisa's learning picture. So you can see Lisa highlighted there at the bottom. And it's her learning picture and the decisions that were made around that picture, which he published in his paper in 92. So you can see on the top, the learning took place between September and December of that school year. You can see that the acceleration and deceleration targets were charted for saying Dolch words, so common words, the most commonly used words. And you can see that the little X's are used to denote the incorrect responses or the deceleration targets, and that those errors or learning opportunities were quite high when they began, and then they started to decelerate, and the opposite was true of the acceleration data. So your acceleration data are your little dots, and they started quite low, and as instruction progressed, they started to accelerate, and then you see a crossover between the dots and the X's, which is what you want to see as a result of instruction. And then he describes a period of time where the student or the learner was either absent or on holiday, and there are no chance days. So that's highlighted there at the top. Across those weeks and days, there was nothing counted, and so those days are skipped, and they are no chance days. And then when this learner returned to school, there was a jump in her errors. So you can see the little X's have gone back up to the top. And there was a jump down in the correct responses. So there was a phase change, and that's indicated by that vertical line. And that shows that the teacher set a goal for praise contingent on improvement for those Dolch words. And then you can see that after that change was made, the correct responses began to accelerate again, and the incorrect were decelerating, but not quite, which is what you want to see, but not quite at the pace that was needed or the rate that was needed across time to meet that goal, where you can see the A indicates when that goal was supposed to be met. So for that reason, there was another phase change implemented, and that was to use flashcard error drills. And that phase change resulted in a much steeper slope of learning. So it was an increased acceleration and faster learning across time. And as a result of that change, based on the learning picture, the learner actually met and achieved that goal before the designated date. Okay. So when we're making decisions based on the learning picture, there are some general strategies that have been developed and used since the development of precision teaching. And some of those are that we might, what we call slice back or forward. If we see a learning picture, maybe that has high errors or high learning opportunities, and not a very fast acceleration of our acceleration targets. So if we're going to slice back, we might go to an easier movement. So for example, if we were practicing times 2 to times 5 math facts and tables, but that wasn't, there was no improvement really in that learning picture, we might slice back to just times 2 and times 3, and stop working on the times 4 and times 5. So we've sliced back to an easier version of this skill, and we're going to practice that instead and build high rates with that. We might also slice forward if you've got a slope that's too steep, that somebody is maybe learning a little bit too quickly, we're not challenging them enough, so we might slice forward, and we might do times 2 to times 7 math facts. Okay. Then we might have a step back or a step ahead. So a step back would be different to a slice back in that it would be a step back to a prerequisite or earlier skill in a curriculum. So for example, writing numbers before writing answers to addition skills or addition math facts, or increasing fluency with single letter sounds before increasing fluency with letter blends. We might also look at increasing the number of frequency building trials or using sprinting. So this is really, if we see a learning picture that we're not probably as concerned with the error rate, but more the slow rate of acceleration in our acceleration data. So sometimes it helps to give more opportunities to actually practice that skill and build a rate, which makes sense. And sprinting is another way of kind of building that rate or that frequency, where we might shorten the 1 minute timing down to 10 or 20 seconds and have an individual practice or build fluency with shorter periods of time and build that up to 1 minute timing. We might do some sprinting if we see that a learner, the rate of the behavioural skill kind of starts slowing down after 30 or 40 seconds. If we see that the learning opportunities are very high and they're not really decreasing, we might do an error analysis and try and figure out why those errors are occurring and implement some kind of corrective feedback or performance feedback to try and establish and remediate those errors. And another thing that we might do based on our learning picture is figure out whether or not we need to use reinforcement, and also what reinforcement schedule and magnitude of reinforcement that we need to use to increase that fluency or frequency. So yeah, sometimes when we see kind of variable learning pictures as well, so maybe it's, varying and bouncing between like 40 to 50 and down again and up again. That can sometimes mean that it's kind of within somebody's ability to do it, but they're not really motivated to, and we might need to look at our reinforcement strategies. So finally, as an overview, and to kind of, I suppose, go back to where we started at the beginning of the workshop, as to the context for using precision teaching and why we should consider using precision teaching. So it allows a teacher to become a scientist or BCBA. Obviously we are all scientists anyway, but it allows everybody to become a scientist in evaluating and making decisions about learning. So we have this excellent tool for quantifying the rate of learning, predicting skill mastery, identifying learning problems, and then assessing the effects of our instructional changes on learning and skill deficits. So it's a really good approach for tackling those can't-do problems in the classroom. Precision teaching also redefines mastery. So we're saying mastery of a skill or a prerequisite isn't, simply getting accuracy with that skill or achieving 100% correct. We're saying it has to occur at a high frequency before it's proficient. And having skills that can be performed at those high levels mean that cumulative curriculum goals are more easily achieved. So when we start at the very beginning of that curriculum and we learn those skills to fluency, and then the curriculum is ever increasing in difficulty, and we have to apply those prerequisites and tool skills to all of those ever increasingly difficult tasks. If those skills and tool skills are fluent, then getting through that curriculum is a lot more easily achievable. And it results, in more useful, more easily applied skills to different areas and different curriculum content. So, in terms of tackling those can't-do problems, it can also be a way of preventing those can't-do problems. So if we're using precision teaching from the beginning and ensuring that when we start with a curriculum, when we start teaching someone to read or do different math skills, that we start out that way, that every individual is proficient with those different skills, and hopefully doesn't result in any of those can't-do problems in the classroom. And then, precision teaching and frequency building, this is probably more anecdotal than anything else. It results in high rates of achievement and a lot of reinforcement. So every time that a learner, does a 1-minute timing, they're getting some sort of reinforcement for correct responding, etc. So again, anecdotally, learners, for the most part, absolutely love doing precision teaching and frequency building. We're setting achievable goals, they're achieving them, they're getting contingent reinforcement, and they become really confident learners. And you can see that confidence generalizing across different skills and different areas in the curriculum. Okay. And I just wanted to finish off by saying that I know that at the start of the workshop, Michelle talked about the Standard Celeration Society. Oh, here, I'll turn on my camera again. She talked about the Standard Celeration Society, and I would highly recommend looking up the Standard Celeration Society and looking at the different events and resources that they provide in this area. So, the Standard Celeration Society is committed to expanding this technology to different disciplines and helping different people use precision teaching and the Standard Celeration chart. And they offer training and tools, etc. So I would definitely recommend looking that up. And really, really excited to say that the first European conference that is being, the first European conference for the Standard Celeration Society will be in Galway in February in 2022. So the Standard Celeration Society has an annual conference, but that conference is usually held in the US. And so for the very first time, it's going to be outside of the US. I think I can say for the very first time with confidence. And that will be in Galway, in Ireland. And I have chosen a very sunny picture of Ireland to give you the impression that that's what the weather looks like all the time. So if you're interested, I would highly encourage you to be there, put those dates in your diary, and be in Galway on the 18th and 19th of February 2022. And hopefully there will be no pandemic and nothing will be online, and it will all be face-to-face, and I might get to meet some of you. And my email address is there as well for anybody that wants to follow up afterwards with questions, because I'm aware I've gone right to the end. And you've used up all the time, Michelle.
That's okay. Thank you so much, Dr. Aoife. I just put Aoife's email address in the chat there for you all, and I will be sending an email. Aoife, if you don't mind just muting just for one moment, sorry, just as feedback. Thanks a million. Yeah, lots of thanks coming through and lots of praise. So thank you so much, Dr. Aoife, for all that wonderful information, and huge congratulations on being, you know, as VP of International Relations at the Standard Celeration Society for getting the first conference outside of the US to be in Ireland. So happy days, so congratulations, Mabrouk. On the screen there, you'll see a QR code. This code is for a evaluation survey, so I encourage you all to follow that right now. I'm going to be emailing everyone tomorrow, and I will be sending that, and I'm desperately copying and pasting the link as well for those of you who are not as familiar with QR codes. So there's the link in the chat as well for the evaluation survey. So please do take a couple of minutes. We really would appreciate it. It really just informs us going forward about what improvements we can make, what you liked, what we can continue to do, etc. And there's also a space in that evaluation form to leave any quotations, like just in terms of feedback about the webinar, so that we can share it on our social media. These can, of course, be anonymous, or you can add your name if you do wish to do so. So in the chat, I've given you a link to the evaluation survey and a link to BACB CEUs, which is very important for all of you out there who are BACB certificants. So what do you need to do? You need to follow that link that I gave you, which I will give again tomorrow. You need to enter your 2 verification codes correctly, and you need to fill in all your information, and you will automatically be issued your certificate. Please give it a few days. We're using a different automatic system, so it just takes a couple of days for you to be issued with your certificate. If you find that you are not getting your certificate, please do follow up with me, and I can get that to you. So thank you so much to Dr. Aoife for this wonderful presentation tonight. I think you can agree with me that this was a wonderful display of an entire field, really, condensed into 2 hours. It's very, very difficult. I know Aoife speaks about 6-hour workshops, but really, I mean, you could spend an entire year talking about it, precision teaching. You know, it's absolutely fantastic. You know, I love presenting on this topic myself. I'm sure everyone in the audience is sick of me talking about it though, so it's great to get a fresh perspective, and from such an expert as Dr. Aoife McTiernan as well. So BACB CEUs, evaluation. There was a couple of questions. Maybe we can just take one, Aoife, because it's...
Yeah, I would say that take my email address. And sure, do follow up with me and ask questions. I'm conscious of not holding anybody up, but if somebody has a question for me, I'm more than happy to chat with them. So please, take my email address and get in touch with me.
Perfect. Yeah, there was a couple of questions, but yes, we can always address them in writing anyway in the follow-up. As you said, we don't want to be holding anything up.
I will. I'll send Michelle all of the resources, and all of the papers that I was using throughout, so that you can send them on.
Yeah, and if I can just say one more thing as well, I just put one link in the chat, and this is something that both Dr. Aoife and I have both experienced, which is the Summer School Institute at Morningside Academy in Seattle in the US. There is a scholarship program for graduate students. So this is really for the students who are attending tonight. You know, we had about 90 attendees tonight. So if any of you are graduate students, they do offer a graduate scholarship to attend their Summer School Institute. And I'm sure Aoife would agree that it's just the most phenomenal learning experience. You really get immersed in the world of precision teaching. You know, you're in the school, watching it, applying it, using it yourself, learning about it from, you know, Dr. Kent Johnson, one of the world-renowned experts in precision teaching. So it really is a phenomenal experience. So for those of you who are students in the audience, I do urge you to click on that link and check it out and consider applying for next year. It was virtual this year, so who knows for next year. So unless, do you have any final words?
One final word, if that's okay. First of all, to say thank you so much, Michelle, for inviting me to do the talk. And thank you so much for everybody for participation. It was amazing and it really, really helped, especially in this online format to get lots of participation online. The last thing I wanted to say is I forgot to mention that Kent Johnson and Rick Kuvina, who is the author of the Precision Teaching book I refer to so often, are both coming to the conference in Galway and are the keynote invited speakers. So yes, they are absolutely brilliant, the two of them, excellent speakers, and I would really encourage you to make your way to that conference if you can. Thank you, Michelle.
Fantastic. Thank you so much, Aoife. Okay, so thank you all so much for attending. You'll be hearing from me tomorrow, and I look forward to seeing you at the next event. So stay home and, yeah, good night. See you the next time.